Hello, class. This is the video solutions for Lab 3536, where we deal with compound interest and then also interest that's continuously compounded. I just want to highlight something. This formula for compound interest will be provided to you on your exam. So the last page of your exam will have this formula, so you do not need to memorize this. And this formula will also be provided with you. And I just want to make sure you understand. Essentially, anytime you see the word continuous in the problem, you're going to use the continuous interest formula. So this AT equals PE to the RT. And then if the interest is compounded monthly or weekly or daily, you'll use this compound interest formula, okay? So if we look at the first problem, it says you have a $2,000 bonus and you want to invest the money and you're going to earn 6.25% compounded quarterly. So these are important words, right? Quarterly means N, the number of compounding periods is 4, because there's 4 quarters in a year. If I said weekly, N would be 52. If I said daily, N would be 365. Okay, if I said annually, N would be 1. Right, so N represents the number of compounding periods. The P is our initial amount, what we start with. R is the interest rate, but you have to make sure you change this to a decimal. So you move the decimal point 2 places to the left and you drop the percent sign. So once you plug in all of the numbers or substitute all of the numbers into your equation, you end up with this 2,727.08. Now people have trouble entering this into their calculator, so we tried to type down here what this would look like into your calculator. So I'm going to type it exactly the way I see it. So 2,000, and then that's the 1 plus the R over N, so that's 0.0625 divided by 4. And I'm going to press the caret key. Some of your calculators will actually raise to the exponent. Some you'll actually see this the caret sign. It depends on the model of your calculator, how old it is. And then just make sure you put this in parentheses. A common mistake I see, if you have an older calculator, if you do not put the 4 times 5 in parentheses, you'll get the wrong answer. So make sure you put this in parentheses. On the newer calculators, it doesn't matter, but just to be safe, I like to put that in parentheses. And you see, this kind of makes sense, right? I put in $2,000. A couple of years later, I take out $2,700. So it looks like I earned $727 in interest. Okay, so that was for money being compounded quarterly. For money that's compounded continuously, well, it's a similar formula, except anytime you see the word continuous, we have to use this A equals PERT. So, oops, I think I just opened up Excel. Oh, there we go. So to use this formula, again, it's still the 2,000, but now this E to the RT, if you press the second key and press the LN down here, there's my E raised to the, and I'm going to use parentheses. My interest rate was 0.0625 times 5 years, right? This is going to be compounded continuously for 5 years. I press enter, and you notice our answers are similar, right? Essentially, if we compound quarterly, I have $727 in interest. If we compound continuously, I have $733 in interest. So it's not a huge difference, right? But if you had the choice of receiving money compounded quarterly versus compounded continuously, I guess you would choose continuously because it results in a greater amount of interest. Now, here's a question. Your lab does not ask this, but what if I were to ask you, how long would it take to double your money if your money was compounded continuously at 6.25%? So you'd have to ask yourself, well, what's double? Right? If I start out with 2,000, double would be 4,000. So if I press Y equals, I clear this stuff out, right? And then I put in, okay, 2,000 E to the RT, right? And then the rate was 0.0625. We don't know. I'm not going to put in 5 here because I don't know how many years it takes. So I'll just put in X, okay? And then double would be 4,000. So if I were to graph this, this would tell me how long it takes to double my money. Right now, listen, the problem didn't ask for this, so this is kind of bonus. Right? So if you know that this is your equation, and we start out with $2,000 at 6.25% interest, and I want to know how long it will take to double our money, we can double the money, right? We start with 2,000, so we put in Y2 is 4,000, and then we want to see when these lines intersect. So I'd have to set up my window. So I'll start at 0, I'll go out to 20, and I need a number, Y max, that's bigger than 4,000 because, well, we're going to have a straight line at 4,000. So when I press window, I'll put in 5,000. And then I graph, and the intersections of these two lines will tell me how long it will take to double our money. And you know the drill at this point. Second, trace, number 5, press enter, enter, enter. And it looks like it would take about 11 years to double my money, right? After 11 years, right, when time, right, is 11, the value for A would be 4,000, right, which is double my initial amount, okay? If I had a negative rate, and I said, what's the half-life? How long would it take to have half my money? Well, then I would change this to a 1, right? Half of 2,000 would be 1, right? So double, you just double this initial value. Half, you would take half. Now, this wouldn't work because my growth rate is, it's positive. So something that's growing would never lose money, right? My 2,000 would never go down to 1,000. So I'm just going to leave it at 4,000 for now, okay? So that's how you would treat a problem that asks you about doubling or halving. Okay, if I go down to problem number 3, all right, so now it says, all right, we have the 3,200, or actually we think we need 3,200 for a down payment, I don't know, for a car or for a house. So if we go back to the original problem, right, we had $2,000 at 6.25% compounded quarterly. We want to know how long it will take for our 2,000 to become 3,200. Right, so here was the original problem, 2,000, right, 1 plus R over N, right? That came from question number 1 right here. And the thing is, we don't know how long it's going to take. So instead of putting a 5 in here, right, we don't want to know how much we'll have after 5 years. We want to know how many years it will take to get to 3,200. So 3,200 goes where the A is. We know the amount in the future is 3,200. We start out with 2,000. Our interest rate is 6.25% quarterly. We just don't know the time. And by the way, you want to make sure you put this 4T in parentheses. So on my calculator, I would enter, instead of Y1, using the compound, the continuous formula, let's clear this out. And I'm going to put in my 2,000, and it's 1 plus 0.0625 divided by 4. Right, that's my R over N, raised to my NT. So the compounding period was 4. I don't know how many years, so I'll put X there, and I'll close that out. And instead of 4,000, right, the question asks us to figure out how long this will take to get to 3,200. So if I graph this, and they give us a window, we can use their window if we want. Our old window will still probably work. I had 20 to 5,000. Let's see if that still works. If it did not, you can actually use this window. Okay, so there's my first line. And then there should be a second line. And we want this intersection. So you press second, trace, number 5 for intersection, enter, enter, enter. And it looks like it'll take about 7.58 years. Okay, so how do you show this on an exam? You kind of just do a rough sketch here, right? It doesn't have to be a Picasso. And then the interpret means, the account will go from 2,000 to 3,200 in about 7.6 years. Okay, so I hope that helps. And then just once again, if I had a problem where my rate was negative, then I might ask, well, what's the, how long would it take to lose half of your money? So you would change the 2,000 to a 1,000, and you'd wait for the intersection, okay, or you look for the intersection. Okay, so just remember, anytime you see a double or a half problem, your initial amount always goes here, and either double or half the value would go on this side, and you'd be trying to solve for time. Okay, it doesn't matter what the equation looks like, right? The equation could have an E in it. Again, if I ask how long will it take to double your money, the double would go on this side, right? The 4,000, and the 2,000 would be your initial amount, and you'd be solving for X. And if I said how long will it take to half the value, well, you would take half of the amount, put it on this side, and you'd solve for the variable for any of these equations. Okay, I hope that helps. And again, these equations will be given to you. I won't tell you what the letters mean, but the actual formula will be provided on the last page of your exam. Thank you for watching.